Up to this point, you heard the term VLAN, Virtual Local Area Network, and that it creates within the switch a local area network. What we're going to do in this module, which takes care of Objective 2.4, Configure, Verify, Troubleshoot VLANs, normal range. We're going to have a normal range and an extended range. We're only worried about the normal range in this course. Spanning multiple switches, access ports, data voice, and then a default VLAN. And then we'll have a second module on we'll do some other configuration and some other terms with it. But in this one, we're going to talk about virtual local area networks. What are they and how to create them? And creating them is really, like in most things, Cisco, not very difficult to do. We just need to know what we're trying to do. So a LAN versus a VLAN. A LAN is just a physical construct. So we have our switch here, and we have maybe a 192.168.1.0 network. Everything in here would have a 192.168.1 address. So it would be a local area network, a single broadcast domain. We've talked about broadcast domains. They're based upon the network address, the network that we have. In a VLAN, we have multiple broadcast domains on the same physical device. So what we've done is taken our switch and the ports, and we've assigned the ports to different VLANs so that they are in the same broadcast domain, can communicate with each other without the use of a router. If we want to communicate between, we'll call these 1, 2, and 3. If we want to communicate between VLANs 1, 2, and 3 different broadcast domains, different networks, we have to have a router to allow that to happen. And we'll configure one a little bit later in order to do that. A VLAN, break it up, and the colors here represent the different VLANs. We have the we'll call it pink or red VLAN, the blue VLAN, the green VLAN, and we have them on different switches. One advantage of a VLAN is that we can create it on different switches, different physical locations, and they can still communicate with each other. We have this special configuration here called a trunk port, which we'll do in the next module. We'll talk about trunking and what's involved in trunking, but for right now, it allows all of the VLANs to travel on it. The other ports that here are going to be access ports in the access layer, access ports, which have end devices on them, can be a member of one VLAN. So access, one VLAN. Trunk, all VLANs, all the VLANs, so that we can allow this sort of arrangement that I can have a switch in a VLAN 1 on the first floor, and then maybe on the 14th floor we have another switch in that VLAN. As long as we have trunk ports connecting them together, we can communicate between those two devices. They're in the same broadcast domain, the same virtual local network. The virtual is the same thing as a local area network, works exactly the same way, except we can have multiples on a single switch, and that's what we're talking about here. VLAN is a logical network that groups devices into a single broadcast domain, and what this is supposed to represent is that we have the different ports here on this switch on the different VLANs. So we have a VLAN 1 here, a VLAN 2 would have these ports, and then VLAN 3 would have the rest of the ports. We could use this here for our trunk, which again we would connect switches together with using a crossover cable, and they would then carry the traffic of all of the VLANs, the tan VLAN, the yellow VLAN, and the red VLAN, created using the configuration capabilities of the switch. Something that we can do with switches, create these things, create some isolation. One of the advantages, my thought, when I was teaching at the university is we would go into the classroom And we could have the student VLAN and the faculty VLAN because we had some restrictions, access control lists that kept students off of certain resources that the faculty could get to. Sometimes you would need those resources in order to do your class. So as long as I was on the faculty VLAN, I could get to all the resources. The students couldn't get there because they were in their own broadcast domain, on their own VLAN, their own local area network, and I was in a separate broadcast domain or LAN or VLAN. So we can get some isolation, allows users in different physical locations to be in the same broadcast domain, the same communicate with each other, same broadcast domain. I'm going to say that several times, but the same LAN, the same local area network, can communicate with each other without having to use the router to do that. Devices in a single broadcast domain. In a LAN, all the interfaces of the switch are in one broadcast domain in a LAN, and this is the default in a local area network. When a VLAN is configured, the interfaces on one switch can be grouped into 2 or more broadcast domains. We can have multiple broadcast domains. Depends on how big the switch is, how many ports that we have, and how many ports we want on each one of those VLANs. The host on the VLAN can be present in different physical segments, and that different physical segments is we have the 14th floor here, and we have a switch that's in VLAN 1, and then we have the 3rd floor here, and we have a switch that's in VLAN 1. So different physical segments, we connect them together with this magic trump port. Again, we'll talk about that, how to create it, a little bit more about it in a few minutes, but just basically it has the traffic from all of the VLANs on it. When one host in a VLAN transmits a broadcast packet, all the other hosts in the VLAN receive the packet. Hosts that are in other VLANs don't receive the packet. Routers are needed to transmit packets between the multiple VLANs, and we've talked about that. So we have VLANs, LANs, VLANs, virtual LANs. We need routers to communicate between them. The VLAN range numbers, I think the easiest thing to, let me bring a packet tracer over here and we can take a look at what these numbers are in this thing. This one up here we're going to look at, we're going to do some configurations on it and hopefully do some demonstration and maybe make a little more sense with this one. Down here, just a switch, 2 switches that we can look at, and this one's already got the show VLAN command here. Show VLAN, you notice that when we have the VLANs, the VLAN name here, this one's default, and the VLAN, this is going to be the number 1. So when we start out, before we've done anything, we have a VLAN number 1, which is called the default VLAN. Status is active. All of the ports are on VLAN 1. So by default, if we don't change anything, then the port is going to be on VLAN 1. We also have some pre-configured ones that we don't really use anymore, but are just there. You can't do anything about 1002, 3, 4, and 5. So these are the standard VLAN numbers, 1 to 1005. The ones that we can create ourselves are 2 to 1001. If we wanted to make a VLAN, we would go into the configuration mode, configure terminal, config T, and then we would type VLAN, now let's say 2, so we have that, and then we can name it, name my VLAN. So now if we do a show VLAN, we have a VLAN 1 and a VLAN 2. We have VLAN 2 my VLAN, but it doesn't have any ports on it. In order to do that, these are going to be access ports, and access ports can be a member of only one VLAN, and they're at the access layer of the Cisco 3-layer model. So we can create VLANs and then put ports onto the VLANs. In order to do that, config your terminal, and then I can go to interface, let's say fast Ethernet, Okay, let's say 0//21. And then I would give it a switch port, and I have to change the mode to access. And once I do that, I can say switch port access VLAN 2. So first we create the VLAN. We change, and it's got to be a space. Then we change the port type, and by default they're auto or negotiate is the actual term. A lot of stuff is automatic in Cisco. And negotiate we'll talk about when we talk about trunk ports. We have to change it to an access port to say that it's going to be there. And then, let's see, we do end, show VLAN, still can't spell kind of, and we have on my VLAN, Fast Ethernet 021. Little thing to remember here, if we wanted to put a whole bunch of ports on a new VLAN, figure T, and I can, instead of typing it in one at a time, I can do interface range Fast Ethernet, and let's do 0/1 to let's say 10. And this says instead of configure interface, it's configure interface range, and we can say switch port mode access, and I'm using the tab key, and then switch port access VLAN 2. And now when I show VLAN, I have put all of those ports on VLAN 2. So now I have two separate entities here, two virtual local area networks, two local area networks existing on a single switch, which have different ports on them. So that is the how to make a VLAN, and what are the default VLANs and the numbers that are available for the standard VLANs. When I go back to the slide here, the default, we cannot delete it. We can move all the ports off of it. 1 to 1005 are the normal range. 1002 to 5 belong to Cisco. They're stored in a VLAN database called VLAN.dat. Ports or VLANs 1006 to 4094 are extended VLAN, and they require some configurations, and it's beyond the scope of ICND 1 to do that. 2 to 1001 are the ones that are available to us to add things to. What we'll see when we showing VLANs, what we actually just saw when I did the show VLAN, the 1 is the default, everything's on it, and then we have the ones that belong to Cisco, the pre-configured ones that are there by default. The default VLAN, VLAN 1, all ports are initially assigned there. We use that. It's used for the management protocols. It's going to be the management VLAN. If we're going to assign, and the only reason we would need an IP address on a switch is if we're going to remotely manage it. So VLAN 1, interface VLAN 1, which would be a virtual interface, would be the one where we would store our IP address, the way we'd be able to communicate with it. Configurations created and stored in the VLAN.dat, the configuration, the VLAN configuration, cannot be renamed or removed, and this is the default VLAN, cannot be renamed or removed. Okay, so I want to bring my packet tracer back up again, and the switch that we've been using here, and if I just do a dir, I have that VLAN.dat database, so it's there. Also, we see here the C2960 LAN-based.bin. This is going to be the iOS, the Internet Operating System, the operating system that's installed on this or loaded in this switch, and they all end with .bin binary files. So get rid of that and get this out of the way. The port types I've kind of addressed and kind of not addressed, but access ports are where end devices are. End devices access these ports, and they are associated with one VLAN, one and only one VLAN on access ports. And then we're going to say, okay, I lied to you. because layer 2 interface to the switch. So it is the layer 2 interface to the switch, and there are two types, data and voice, and this is where I'm going to say I lied to you, because if we have a voice VLAN, voice over IP, we can then have the port be a member of two separate VLAN. In order to do that, we'll talk about that when we talk about some tagging here in a little bit, and how that works. Tagging is when we mark the packet, the frame, as a member of a particular VLAN. We can have static, which we just did. We add the MAC address, or dynamic. The switch detects the MAC address in the ports themselves. But we can have static and dynamic membership of the VLANs also. Static is when we add the VLANs, or the ports to the VLANs, which we just did. And dynamic is when we have a piece of software that is enabled to assign it based upon MAC address. So the types of VLANs we can create with a VLAN configuration command, and as well as, which is what we did. We went in and created a VLAN whatever, and then we added the devices, the ports to the VLAN. We have a dynamic VLAN. It's a VLAN, not an address assignment. A dynamic VLAN, and we have the VMPC, the server here, that keeps track of the MAC address, and then it automatically adds that MAC address to the VLAN regardless of where it plugs in to the switch. Try to get the text on the background a little bit better, but the virtual VMPC, the server here, keeps track of the MAC addresses and which VLANs they are associated with, and automatically assigns them as we plug the device, the computer, because you recall each one of them has a unique MAC address. So as we plug it in, then we are able to discern which VLAN, or the management device, which VLAN it belongs to, and automatically configure it to be on that VLAN. And over here it's a rule breaker, two VLANs on one access port, and that's when we have a voice VLAN. Voice VLAN, we have a data VLAN and a voice VLAN, so that we keep the telephone calls separate from the data. So we talked about what is a VLAN, why we use VLANs. We're going to separate. We get a little bit of security from it. We get separate broadcast domains in order to do that. We created a VLAN, talked about the default VLAN, VLAN 1, which is everything is by default a member of the default VLAN. Access ports are where we have end devices. We have another type of port that we're going to discuss in the next module, which is the trunk port. Types of VLANs, where we had the static, go back to this, the static, the dynamic, and then the voice VLANs were the types of VLANs that are available. So in the next module, we're going to talk about tagging, trunking, and voice ports, how we get there, a couple of other features of switches. See you there.